Maaf, ay anjinay.
Yesterday, we packaged a model into one reusable pipeline object. Today, we're starting something new, unsupervised learning.
500 customers. 0 labels telling the model what a segment even is.
It still finds 4 clean groups.
And marketing recognizes every single one of them.
No answer key. No ground truth. How does that even work?
Episode 23, K-means clustering. Our first algorithm that never sees a label.
Every algorithm so far had a Y column, a right answer to learn from. This dataset doesn't have one.
Just customers, age, spend, visit frequency. Nothing telling us the groups.
There's no segment column to predict because nobody defined the segments yet.
The job isn't prediction anymore. It's discovering structure that's already there. K-means is built on one simple idea. Drop K random points called centroids onto the data.
Assign every point to its nearest centroid. Move each centroid to the average position of its assigned points.
Repeat. The centroids drift toward the real centers and settle. Let's watch this converge live on a real scatter of customers.
For random centroids drop in. Right now they mean nothing. Iteration 1. Every point snaps to its nearest centroid. The centroids recompute, each one moves to its group's average.
Iteration 2. Points reassign. Some switch groups. Centroids move again. By iteration 4, almost nothing is moving anymore.
That's convergence. For stable groups, found with 0 labels.
But how do you pick K in the first place? Run K-means for K equals 2, 3, 4 all the way up.
Plot inertia, how tightly packed each cluster is against K.
Inertia always drops as K grows. The question is where it stops dropping fast.
That bend in the curve is the elbow. That's your K.
K-means gives you 4 groups of numbers. It doesn't name them.
That part is on you.
Look at each cluster's averages. High spend, frequent visits, loyal customers. Low spend, rare visits at risk of churning.
The math finds the groups. You give them meaning.
In code, this is a short loop plus one fit call. Scale the features first. K-means is entirely distance-based.
Loop K from 2 to 8, storing inertia each time. Plot the elbow curve, pick K, fit K-means one more time.
Labels underscore gives you the cluster for every single customer. If this is clicking subscribe, hierarchical clustering is next. Here's the finished project. Cluster 1. High spend, frequent visits, your loyal core. Cluster 2. High spend, rare visits, big ticket, occasional buyers. Cluster 3. Low spend, frequent visits, bargain regulars. Cluster 4. Low spend, rare visits, customers slipping away.
For groups, 0 labels going in. A real marketing strategy coming out.
A few mistakes come up constantly here.
Skipping feature scaling, one large range column can dominate every distance.
Picking K by gut feeling instead of the elbow method.
Assuming every cluster is meaningful without actually reading the averages.
Using K-means on clusters that aren't roughly round, it assumes spherical groups.
Every one of these produces confident-looking groups that mean nothing.
So when should you not reach for K-means?
Clusters with weird, non-round shapes, K-means will cut them wrong.
Clusters of very different sizes or densities, it tends to average them out. Don't know how many groups exist at all? Try hierarchical clustering instead. Outliers and noise in the data. Discan handles those far better.
Both are exactly what next episode covers.
Quick recap before we go.
The problem. No labels, just structure waiting to be found.
K-means, assign to nearest centroid, recompute, repeat until it settles. The elbow method, plot inertia against K, pick the bend. Always scale your features first. Distance is everything here.
The algorithm finds the groups. You give them meaning.
Where we are in the series.
We just crossed into a whole new section. Unsupervised learning.
Episode 24. Hierarchical clustering and Discan. The clustering methods that handle what K-means can't. Episode 24, Hierarchical Clustering and Discan. No need to choose K up front. Hierarchical clustering builds a tree of groupings.
Discan finds clusters of any shape and flags outliers as noise.
2 more tools for the shapes K-means gets wrong. Subscribe so you don't miss it.
Your challenge task for this episode.
Take any dataset with at least 2 numeric columns and no labels. Scale the features first. Run K-means for K equals 2 through 8 and plot the elbow curve. Pick a K from the bend, fit K-means, and plot the clusters in 2D.
Write 1 sentence describing what each cluster seems to represent.
Solution is in the repo. Think before you look. 500 customers. 0 labels. For clean groups anyway.
Nobody told the model what a segment was.
It found the structure that was already there. Episode 24, Hierarchical Clustering and Discan drops next. Subscribe. Comment below. What's a dataset you'd love to see clustered?